guys, welcome to my YouTube channel. Today we solve a column internal question, obtain normal equation and write the algorithm for linear regression. Okay, so here we write a straight line equation. Y1 is equal to a1 x plus a0. Here a1 and a0 are the variable which is give the best straight line. Okay, so let's the case 1 and deviation between the tabulated value of x and y. So in the case 1, the summation of I is equal to 1 and y1 minus yi bar square is equal to summation of I is equal to 1 to n and square bracket y1 minus a1 ai and a0 x0. And in the second case, we obtain the straight line x is equal to b1 y plus b0 and deviation would be summation of I is equal to 1 to n and xi minus xi ka bar square whole square is equal to summation of I is equal to 1 to n and xi minus b1 yi plus b0 whole square. And the straight line obtained in the two cases are different. Okay, so in the obtaining the equation y is equal to a1 x plus a0, it is assumed that the x is an independent variable and y is a dependent variable, and the deviation yi minus yi ka bar measured the error. The linear least square fit equation obtained in the case of case 1 is called the linear regression of y on x. So given the problem, we have to decide which is independent or dependent variable. So we have now we will discuss the method of calculation a variable a0 and a1 in the linear equation y is equal to a1 x plus a0. We will put the equation number 1, and by minimizing the sum of square of error between the measured value and that given by the equation 1, we want to minimize as given by. So the minimize as would be min summation of I is equal to 1 to n and yi minus yi ka bar whole square is equal to min summation of 1 is equal to I is equal to 1 to n and yi, and we put the y1 bar value a1 xi plus a0 ka square, and here s is a function of the unknown variable, and deviation of x with respect to x0 and x1. So v deviation of x with respect to a0 is equal to summation of I is equal to 1 to n and 2 into yi minus a1 xi minus a0 into minus 1 is equal to 0, and with v deviation of s with respect to a1 is equal to summation of I is equal to 1 to n and 2 into yi minus a1 xi minus a0 into minus xi is equal to 0, and we put the equation number 2 and 3 in this to some deviation, and equation 2 becomes we solve with it. So we write a summation yi is equal to a1 xi1 minus n x0 is equal to 1, and equation 3 becomes minus x summation of xi yi plus ai summation of xi ka square plus xi a1 is equal to 0, where summation is equal to summation I is equal to 1 to n. And in the next step, now we solve and obtain the those equation number 2 and equation number 3. So we rearranging these equations and find the n a0 plus a1 summation of xi is equal to summation of yi, and x summation of xi ai plus a1 into summation of xi का whole square is equal to summation of xi into yi. So the solution multiply x. In those equation we in first equation we multiply summation of xi, and in the second equation we multiply n. So we multiply those equation xi x summation of xi and so we find the those two equation a n a0 and summation xi plus a1 a1 summation xi का whole square is equal to summation of yi summation of xi, and in the second equation n a0 x summation of xi plus n n a1 summation of xi2 is equal to n summation of xi into yi. So we solve those equation, we solving those equations, and we find the some a1 value. So we minus the an, so we minus the n a summation of xi and n a, we minus n those term, and we minus the a1 summation of xi का whole square minus n a summation of xi का square is equal to minus the summation of yi summation of xi into n summation of xi into yi. So we solve this equation and we will find the a1 value. So a1 value is equal to summation of xi yi minus n summation of xi yi upon summation of xi का whole square minus we find the we take a common 1 minus n. So we multiply the 1 minus n, and we those common value we multiply the inside. So we will find the n summation of xi yi minus summation of xi into summation of yi upon n summation of xi का whole square minus xi का whole square summation of xi का whole square. So so this a1 value we put the equation number, we put the we put the upon, and we find the a0 is equal to summation of yi and summation of xi का whole square minus summation of xi into summation of yi and xi upon n summation of xi का whole square and summation of xi का whole square. Now so we will find the a1 and a0 situations. So the two equations are called the linear equation, and given the coefficient of the linear least square fit line are called the linear regression coefficient. Okay, so we will find the two situation a1 and a0, and we these two equation help we will find the linear regression equation. Okay, so let's start the algorithm for a1 and a0. Okay, first of all we read n numbers, and in the second step we take a sum x is equal to 0, and in the third step we take a sum x square is equal to 0, and sum y is equal to 0, and sum x into y is equal to 0. So this four values are take is equal to 0. Okay, and we iterate a for loop I is equal to 1 to n to do, and read x and y value. Okay, so in the next step we sum x is equal to sum x plus x, and sum x square is equal to sum x square plus x square, and in the next step we take a x y is equal to sum y plus y value, and in the next step sum x into y is equal to sum x y into x into y, and we end of the for loop, and we find the denominator, and we have the same denominator. You look in a1 and a0 situation, and there are the same denominator, and summation of xi ka square minus summation of xi ka whole square. So here we write a denominator, and denominator formula is n into summation of xi ka whole square. So here we write n into sum of x square and minus summation of xi ka whole square. So here we write a summation of x and summation of x. Okay, then we write a0 value, a0 upon value summation of yi and summation of xi ka square, so summation of yi. So here we write a summation of yi, so summation of y into summation of x square. So here we write a summation of x square minus, and in the next term summation of xi, summation of xi into summation of xi into yi. Okay, so here we write a summation sum x into summation of x and y, and here we write upon this denominator. So here so we can put the denominator upon the this term. Okay, and we write a1 from the formula. So a1 value, so a1 formula is n summation of xi and yi, summation of xi and yi. So here we put n into sum of x into y minus sum x minus sum y here, because summation of xi and summation of yi. So here we write a sum of x into sum of y divided by denominator, and we write a0 and a1 a0 and a1 values, and we print a1 and a2 value, a0 and a1 value, and linear regression equation, and write the a1 and a0 and stop the algorithm. Okay guys, I hope guys you understand the question answer. Okay, thank you my watching YouTube channel.